our universe may not have a beginning. For years, we believed in the theory of the Big Bang. But now real observations of the early universe show us something completely different. Behind the Pandora Galaxy Cluster, the James Webb Telescope has discovered a mysterious structure so old and so large that it could never have existed in a young universe. This gives us further evidence that our theories about the Big Bang and the age of the universe are wrong. There may never have been a beginning. The idea that something could have no beginning and no end causes problems for many of us. We are used to thinking in spatial dimensions where things and processes have a beginning and an end or boundaries. Scientists also struggle with infinity because it poses unsolvable mathematical problems. Scientists can only calculate with quantities of length, height, and width within a fictitious space. If our universe is truly boundless, then it has no height, no width, and no length. In fact, however, most of our current theories about the origin and development of the cosmos are based on calculations that assume a space that is closed in some way. Since the James Webb Space Telescope has provided us with more and more evidence that the previous explanation of the development of the universe is not correct, other theories are becoming more likely. At the beginning of time, galaxies appeared that look as if they are already billions of years old. These early galaxies should have shown signs of an early stage of development. Researchers also expected to finally see the extremely bright stars of the first generation through James Webb. But here too, there has been no sign so far. All we see are structures that look so old that the Big Bang could not possibly have taken place 13.8 billion years ago. What is behind the Pandora Cluster? In February 2023, NASA published another deep image by James Webb. Here we see the Pandora Cluster, also known as Abell 2744, with the incipient merger of three massive galaxy clusters visible in the foreground. This fantastic discovery was made possible by Webb's near-infrared camera, NIR-CAM. Webb exposed the individual sections of the cluster for up to 6 hours and then perfectly assembled the new depth image from 5 individual images. The image shows around 50,000 light sources, the oldest of which are expected to reveal further secrets of the early universe. There is much more to this image than just another stroke of genius of our telescope technology. The enormous cluster acts as a unique gravitational lens and magnifies all objects behind it due to the curvature of space-time. The ultra-deep near-infrared and NIR-CAM observations before the epoch of reionization program, UNCOVER for short, are responsible for this image, and researchers took a close look at every trace of light on the image. They noticed something that once again calls our standard models of cosmology into question. Behind the cluster, a structure became visible that is so large and massive that it's incompatible with our previous explanatory models of the early universe. UNCOVER has actually set itself the goal of capturing the first light signal from the epoch of reionization. At that time, the universe is said to have been largely dark. However, the image again shows that some of the points of light are very probably galaxies that are well over 13 billion years old, which again means that they are actually too old for our explanations. This image adds to the debacle of astrophysics with a mysterious structure. Initial measurements showed a redshift value of Z equals 7.9, meaning the object was already present around 650 million years after the Big Bang. The structure could be a protogalaxy cluster, but how can huge galaxy clusters have already formed 650 million years after the Big Bang if, at that time, there were supposedly at most isolated first stars or protogalaxies? So, the old theories are once again being challenged, and this discovery increases the probability of a much older or infinite universe. The photometric NIR-CAM data from the image has now been made available to many international research teams, and astronomers around the world are now working together to find out the truth. What if the Big Bang never happened? It's exciting. We are currently facing more new possibilities in astronomy than we have for a long time. Before the telescope was launched, researchers were actually expecting the long-awaited confirmation of their theories, but now completely new scientific dimensions are opening up, and we are going to experience changes. What could all this mean? Now, we may soon be able to look even further back in time. And if we still can't find any signs of an early universe 14 billion light-years away, we will at least know for sure that our universe must be much older than previously assumed. This would not yet be proof of infinity, but this possibility would become more likely again. Let's take a look at what supports this. The uniform distribution of the cosmic microwave background radiation across the entire sky indicates that the universe is homogeneous and isotropic on a large scale. Both can be interpreted as an indication of an infinitely extended universe. The Planck Space Telescope also showed us that the universe has a flat geometry. Some scientists also interpreted this as a possible indication that our cosmos is infinitely extended in all directions. There is another fact that we must not overlook when considering the question of the infinity of our universe. No one has yet found an end to the previously known universe. We survey more than 90 billion light-years, but there is no evidence of an end. Ideas about the edges of the universe have so far been pure scientific mind games but not proven facts. James Webb's discoveries now indicate that there is no beginning on the timeline either. Proving an infinite universe will be difficult because even the best telescope can never show infinity. Even if we one day travel through space in spaceships, we could never know for sure that it has an end until we find it. What would an infinite universe mean? It sounds fascinating to live in a universe that goes on, has no beginning and no end, and has always been there. Only our science has difficulty with this idea. There are the aforementioned problems of describing such a universe scientifically and accurately. Infinity would mean that we are very unlikely to succeed in doing just that. We can explore partial areas and make approximate predictions as to which forces are at work there and where they come from. But the entirety of the infinite universe would probably elude mathematical and scientific observation. Who says that we have to measure and scientifically explain every corner of the magnificent universe? We have to ask ourselves why we are so meticulously searching for this information. An understanding of the universe. It's because we are looking for answers about our own origins. Where did it all come from? Who made it? And why is it here? Natural science tries to explain these questions with formulas and calculations and is now reaching its limits. However, open-minded scientists also see the new discoveries as an opportunity to learn more about the cosmos in a completely new way. The findings may enable us to reach new levels with our research. So far, we have to admit that despite many theories and telescopes like James Webb, we still know very little about the universe. The infinity of the universe could also mean that we are in a kind of time-space loop or in a very well-made holographic projection. This would mean that we need to evolve our consciousness and brains to understand the true nature of the universe. Can we get to the truth with a quantum computer? Now we come to an exciting chapter in the exploration of the universe that could truly be a revolution. Quantum computers may soon be so powerful and intelligent that they will provide us with answers to all the questions without us having to search for long. These fascinating machines use the principles of quantum mechanics to process huge amounts of information or perform complex calculations. Quantum computers use qubits, which, unlike the bits of classical computers, can not only assume the states 0 or 1 but also superposition positions of these states. As you may know, qubits combine all possibilities and only take on a certain form when they are measured. This behavior shows that qubits theoretically contain all the possibilities and all the knowledge of this universe. We just have to learn to crack the code of quantum language and program the technology in such a way that it provides us with answers that go far beyond observational possibilities and classical mathematical calculations. Let's take the problem of the incompatibility of Einsteinian physics with quantum mechanics. So far, only string theory exists that can close the gap between the two, but we cannot prove string theory because it includes invisible dimensions. There are now countless variants of string theory, and none of them quite fit. A quantum computer can reconcile all this information and show us our mistakes in an unprecedented way, and the computer could replace existing gaps and misconceptions with coherent calculations. We might even be able to combine quantum computers with artificial intelligence, and then we would probably have access to almost endless knowledge. Telescopes would then be another fun way for us to observe the beauty of the universe, but we would no longer have to painstakingly piece together what we see into a cosmic puzzle. Scientists predict that even the simplest variants of quantum computers will be able to plausibly show us whether dark matter really exists. So far, we have used the assumption of dark matter to explain anomalies in the movement of galaxies, but its existence has never been proven. The quantum computer could provide us with all kinds of explanations for the phenomena that we have so far explained with dark matter, and also show us whether the concept of dark matter is real or mistake. The first prototypes of these computers are already in use. At the moment, the developers are still having problems with the sensitivity of these futuristic machines. Quantum computers are extremely sensitive to vibrations and are only operated in specially sealed and insulated rooms. Cooling poses a further challenge. Basically, however, these processes are nothing more than a further development of the gigantic computers that existed in the 1960s and 70s. Today, we have small laptops and smartphones. The people who operated the first monster computers could never have dreamed of that back then. Nevertheless, it only took a few decades for computer technology to advance to the point where it can be found in almost every household today. Subscribe now and look forward to upcoming video hits.